Let's write this down. Exponents. We've done exponents before, haven't we?
Yeah.
People are exponentially fun. Exponents. They are also known as powers. And an example of an exponent would be this. 5 to the second power, or 5 squared. This bad boy right here is the exponent, also known as the power. And this number here, what's the 5 known as, you ask? Nobody knows what it is? That number is called the base number. And what does an exponent tell you? People get that mixed up with like multiplication. They think this is 5 times 2. Definitely not 5 times 2. Chase, it is.
You multiply the same number that many times.
Right, well, it says, this is how you would say it here. The exponent tells you how many bases get multiplied together. Not added together, but multiplied together. So if you have 5 to the second power, that means you have 2 5s times themselves. And the answer to that is not 10, that's 5 plus 5. 5 times 5 is 25. Or if you had 5 to the third power, that's 5 times 5 times 5. It's 3 5 times themselves, which is 5 quarters is how much money? $1.25. If you had 5 to the fourth power, anybody? 5 times 5 times 5 times 5. Nobody? Liv!
No.
We taking a shot in the dark? $625. Now, a couple special cases for those of you that are in the scholastic bowl in case this comes up. I don't know if it comes up here or not. What do you suppose 5 to the 0 power is? Let me tell you, you will be wrong. Zach?
Is it 0?
Huh? You're wrong. It's a good thought, though. Madison?
5.
You're wrong. All right.
You can't do it.
You are wrong. You can have, and you can get to the 0 power. Look at that. Nobody ever guesses it, but it does have an answer. Madison!
50?
No. 5 to the 0 power would certainly be less than 25.
I don't know.
Notice how these do keep going down. Caleb!
-5?
No! 5 to the 0 power is 1.
Oh, yeah.
Oh.
Now listen, did we already do that before? Is it in your notes?
No.
Is it Madison?
Yes.
And here's what to remember. Anything, ladies and gentlemen, anything to the 0 power is 1. Doesn't matter what it is. If it is to the 0 power, it's always going to be 1. You can have 5 million to the 0 power, and the answer to that is 1. You can have the letter A to the 0 power, and the answer to that is 1. You can have Zachary Roth to the 0 power, and the answer to that will be 1. Anything to the 0 power is 1. Now, with that being said, how about this? What about 5 to the first power? That one's a pretty easy guess, I think. Joseph?
5?
It is. Anything to the first power is itself. Anything to 1 power is itself. And then make sure, just for 2's and 3's, ladies and gentlemen, we have special names. Usually we don't say 5 to the second power, we usually say squared if it's 2. And usually we don't say to the third power, we usually say cubed. Those are the only two that we really have names for. Otherwise you just say 5 to the fourth power, 5 to the first power, 5 to the 0 power, 5 squared, 5 cubed. I don't know why that is, but apparently we like squares and cubes enough to give them their own special names. So, let's say we've got this problem here, 3 to the fourth power or 4 to the third power. 3 to the fourth power compared to 4 to the third power. Now please, when you see these, just sit down and think about them. The natural reaction to look at that is say those are equal because, well, you see a couple 4s, a couple 3s, and blah, 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 blah. Maybe you're thinking the answer to those are 12. It isn't because you really need to just do this out. 3 to the fourth power means that you have 3 times 3 times 3 times 3, or 9 times 9 give you the same thing. This is 81. 4 to the third power, 4 times 4 is 16. 16 times 4 is 64. What is bigger? 81. 81. So please get it out of your head. The most common mistake is people see this and they go, the answer to that is 12. No, it's not 4 plus 4 plus 4. It's not 4 times 3. It's 4, 3 fours times themselves. What other exciting things do they ask? Oh, and then they'll ask something like this. Write the prime factorization of 72 using exponents. Which means this. You still start this the same way. You break down 72. 72 breaks down into what? Let's go 8 times 9. 8 breaks down into 4 times 2. You can stop at the 2, and 4 breaks down into 2 times 2. This is not new, right? You've done this before. 9 is 3 times 3, right?
Yep.
So you end up with 2 times 2 times 2 times 3 times 3 as your prime factorization. If they ask you to write that using exponents, that means instead of writing 3 2's there, you go 2 to the third power, because it's 3 2's times themselves, times 3 to the second power. This would be the same thing as that right above it, just using exponents. Occasionally people ooh and ah when I tell them that. Probably not you guys so much.
We haven't caught on that yet.
No, most people don't. Generally speaking. But generally, that was the common use of that.